We have talked about the trig functions for in the right triangle, right? We have just a quick review. If you have right triangle, right, and this is theta, so here theta is a acute angle. Then we know the trig function sine equals the opposite over, this is the opposite, this is the hypotenuse, and this is adjacent, right? The sine is equal to opposite over hypotenuse, cosine equals adjacent over hypotenuse, and the tangent theta is equal to opposite over adjacent. And for other cofunctions, you can use the reciprocal, right? For other functions, not cofunctions, for other functions, other trig functions, you can use the other three functions, you can use the reciprocal. Okay, so now let's extend this one. So in the right triangle, this theta is acute angle, right? What about the theta is not acute angle, which is a general angles, okay? So now let's extend the definition of the trig functions to the general angles. Okay, so the general angles, we use this angle in our xy coordinate system. Okay, so now let's look at when the terminal side is in the first quadrant. Okay, this is the first quadrant, this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant, right? If the terminal side, initial side is the x-axis, and the terminal side is here, okay? And this is our theta. This is our theta. So if we pick an arbitrary point on the terminal side, which is this point is denoted by x and y. So here is x, right? This part is x from here to here is x. I use another color. So this is x, right? And y is here, right? This is the y. And we call this line the origin to this point, which is called R. So our sine theta is equal to the opposite over a hypotenuse. The opposite is y, right? The hypotenuse is R. R is the distance between the origin to the point, right? Arbitrary point. Cosine theta is adjacent. Adjacent is x, right? Over hypotenuse R. Tangent theta is equal to what? Y over x, right? The opposite over adjacent. The reason is this is a right triangle, right? So you can use. So this is the terminal side is in the first quadrant. Okay. What about the terminal side in other quadrants? For example, in the second quadrant, we still use the same definition. If the terminal side is here, okay, so our angle looks like this one, right? This is our theta. So this theta is not acute angle anymore because it's greater than pi over 2. So we still pick arbitrary point x and y, right? We still pick arbitrary point. And this side from the point xy to r, to the origin, this is called r. The distance is called r. So we still define our sine function, sine theta, to be y over x. Okay, y over x. Y over r. And the cosine function is still x over r. Right? and tangent function is y over x. So we use the same definition as the terminal side in the first quadrant. Okay, so the cosecant theta is 1 over sine, so it's r over y. So here we need our y is not equal to 0. And the secant theta is r over x, so here x cannot be 0. Cotangent theta is x over y, so y is not 0. So here for tangent x cannot be 0. Okay. So no matter the terminal side in the second quadrant or in the fourth quadrant, in the third quadrant, we always use this definition. Okay. Always use this definition. So now let's look at one example. Okay, so before that, let's look at this remark. This is a very important remark, which is called the sign of trig functions. Okay, so now let's look at first. Let's look at the sine theta. This is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Okay. For the sine theta, when the terminal side is in the first quadrant, so the xy in the first quadrant, xy is positive. So everything is positive. So the sine function is always positive here. Right? Because r, the distance between the point, r is always positive, right? So here r is always positive. No matter which quadrant it belongs to. In the second quadrant, our sine theta is y over r. R is always positive. So y in the second quadrant is also positive. So here is also positive. Right? In the third quadrant, y over r, y is always negative in the third quadrant. R is positive, so this is negative. And here is negative also. Right? Because the y coordinate is, the y is, sine is y over r. So y is negative, so it's always negative in the third and the fourth quadrant. For the cosine theta, cosine theta equals what? Equals x over r, right? This is y over r. So equals x or r is positive. So in the first quadrant, the terminal side is in the first quadrant is positive. In the second quadrant, x is negative, right? So it's negative. In the third quadrant, it's also negative and positive here. The tangent theta. Tangent theta is equal to y over x, right? So in the first quadrant, x and y are positive, so it's positive. In the second quadrant, x is negative, y is positive, so the division, the quotient is negative. In the third quadrant, both are negative, so the quotient is positive. And the third quadrant is negative. Okay, so you should be very familiar with this, the sign of the different trig functions. So now let's look at one example. We let a point 12 and negative 10 be a point on the terminal side Okay, then we need to determine the trig functions. So the first thing is, where is this point? negative 12, or 12 and negative 10. 12 is here, for example. 10 is here, negative 10 is here. So the point would be here. So the terminal side is in the fourth quadrant, right? The terminal is, this is the 12, negative 10. So this is our angle, right? Of course, you can have one more round, more rounds, more revolutions, add more revolution, but this is a angle in from 0 to 2 pi, right? So we can assume that so here, for this point, so our x is equal to 12 and y equals negative 10. So we need to calculate r. R is the distance between the origin and this point. This is r, right? This is r. So r equals, this is the 12 minus 0 square plus negative 10 minus 0 square. Okay, if you calculate, it would be equal to 2 times square root 61. So this is our r. So now we can calculate the trig functions. Sine equals what? Sine theta equals, this is our theta. Theta equals y over r. So y is equal to negative 10 over 2 square root 61. Okay. So you simplify, it would be negative 5 over square root 61. Cosine theta is x over r. X over r, x is 12. 12 over 2 square root 61. So this is 6 over square root 61. And the tangent theta is y over x. Y is negative 10. So it's negative 10 over 12. So which is negative 5 over 6. So this is the trig function. So the cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, so next we want to look at the trig functions on the values of the trig functions at quadrant angle. So what does this mean? Quadrant angles means the terminal side of the angle is on the axis. Okay, it's on the axis. So here, let's look at some special angles. Here is the 0 radian, pi over 2, right? The terminal side is on the, so 0 means the terminal side is on the positive x-axis. And the pi over 2 means the 0 side, the terminal side is on the positive y-axis. Then pi, which means the terminal side is on the negative x-axis. And 3 pi over 2, which means the terminal side is on the negative y-axis. Then the next one is 2 pi. 2 pi is the same as 0, right? Is the coterminal angles of 0. So now let's look at let's just look at some theta equals 0. Okay, theta equals 0, that means the terminal side is on the x-axis. Okay, the initial side and the terminal side is here. Terminal side is here. Right, this is the terminal side. So we pick an arbitrary point. This point is what? The coordinate is x0, right? So our sine theta, sine 0, theta equals 0, which is y over r. Y is 0. R is what? This point to the distance between the point and the origin, which is x, right? So this is equal to 0. So sine 0 is 0. Cosine 0 is x over r. So here is x over r is what? This is r, right? This is r equals x. So this is x, so which is equal to 1. So this should be 0. Tangent 0. Tangent 0 is y over x. So y equals 0, x is x, just 0. Okay, so for 0 radian, then sine 0 equals 0, cosine 0 equals 1, and tangent 0 equals 0. If for the theta equals pi over 2, so that means the terminal side is on the y-axis. This terminal side is here, right? So this is the right angle, theta equals pi over 2. Okay, so now let's look at the sine pi over 2. So we pick an arbitrary point, which is, this point is 0, y point, right? So the distance between this point and the origin, which is y, so r equals y. So pi over 2 equals what? Y over r. So which is y over y, which is equal to 1. Cosine pi over 2 is equal to x over r. X is equal to what? Equal to, this is x equal to 0, right? X equals 0, so this is the r equals y, so it's equal to 0. Tangent theta, tangent pi over 2, which is y over x. Y over x, but we have x equals 0, so it becomes y over 0. This is called undefined. So that means when the theta is pi over 2, or the coterminal angles of pi over 2, tangent theta is always undefined. Okay, so let's look at theta equals pi. Theta equals pi, which is here. The terminal side is here. Right? So this is our theta. And then we pick an arbitrary point. This is the x and the 0, right? But keep in mind this x is negative. So our distance from this point to the origin, which is what? Which is the absolute value of x, right? Since x is negative, so r equals negative. So which it means it is absolute value is always positive, right? So it's equal to negative x. So our sine pi is y over r, which is 0 over negative x, which is 0. Cosine pi is x over r. X is x, r is negative x, so which is negative 1. Tangent pi is y over x, so this is the 0 over x, which is 0. So theta equals 3 pi over 2. So the terminal side is here. This is the terminal side. So this angle is theta equals 3 pi over 2. So what is the, so we pick arbitrary point. This point is y0, but keep in mind this y is negative. So here the distance is r is equal to the absolute value of y, which is y is negative, so it's equal to negative y. So it becomes positive, right? So our sine 3 pi over 2 is equal to what? Equal to y over r. Y is y, r is negative y, so it's negative 1. Cosine 3 pi over 2, which is x over r. X is always 0. 0 over negative y equals 0. And the tangent 3 pi over 2 is equal to y over x, but x equals 0, so it's a y over 0, so it's undefined. Okay, so in other words, the tangent of angle if the terminal side is on the y-axis for this case, and for this case, then the tangent theta is always undefined. So now let's summarize it. You also need to memorize these special angles. So we have 0, which is 0 degree, pi over 2, this is 90 degree, and pi, this is 180 degrees. So you will see that we will often, in the future, we will often use the radian instead of using the degree. 3 pi over 2, so this is 270 degree. And then 2 pi is the same, trig function is the same as the 0 radian, okay? And the sine theta, cosine theta, and tangent theta. Sine 0 equals 0, cosine 0 equals 1, tangent 0 equals 0. Sine pi over 2 equals 1. Then cosine pi over 2 equals 0. Then tangent pi over 2 equals undefined. Does not exist. Sine pi equals 0. Cosine pi negative 1. Tangent pi equals 0. Sine 3 pi over 2 equals negative 1. Cosine 3 pi over 2 equals 0. And the tangent 3 pi over 2 is undefined. So you need to memorize this table. So now let's look at this example. We want to find the tangent of negative 7 pi over 2. Okay, negative 7 pi over 2. So the first thing is we need to determine the terminal side, right? So look at negative 7 pi over 2, which can be written as what? The negative 2 pi minus 3 pi, negative 2 pi minus 3 pi over 2, yes. So negative 2 pi is 1 revolution, but in the opposite direction. Right, 3 pi over 2 is just 3 pi over 2, but in the opposite direction, right? So the terminal side, so the angle should looks like this one. We start from here. This is the negative 2 pi. Then negative pi over 2, negative pi, negative 3 pi over 2. So the terminal side is here. Okay, the terminal side is on the y-axis, right? Positive y-axis. We know on the positive y-axis, the tangent is undefined. Undefined because which is y over x, but the x coordinate is always 0 when the terminal side is 1 on the y-axis. Okay. Now let's look at another one, which is about the sine. So if we have, suppose, tangent is greater than 0, and the sine theta is less than 0. Find the quadrant. Of Find a quadrant where the terminal side of the theta angle lies in. Okay, so this is so we needed to know that the tangent theta greater than 0 in which quadrant the tangent theta is positive. So we needed to go back to look at the sign. So tangent is in the first and the third quadrant, right? So first and the third. So it implies that this terminal side theta is in the first and the third quadrant. Okay, and we also know sine theta is less than 0. Sine theta less than 0 means theta is in which quadrant? The terminal side. Theta is, sine is negative. So in the third and the fourth quadrant, right? So it's in the third and fourth quadrant. So put together, because these two conditions should be satisfied at the same time, so it implies that the only choice of theta must be in the third quadrant. So the terminal side of the theta must be in the third quadrant. Let's look at this example. Suppose our tangent theta is -3/7 and sine theta is positive. Find the cosine theta. Okay, so the first thing we need to know is which quadrant it belongs to of the theta, right? Tangent is negative. Is -3/7, which is less than 0. So it implies that theta is in the second and the fourth quadrant, right? If you go back to look at the sign. And sine theta is positive. It means theta is in the first and the second quadrant. So put together, it means theta is in the second quadrant. So the terminal side is here. Terminal side is here. Okay, since tangent theta equals x/y, so there is a point on this one, the ratio of x coordinate and the y over tangent theta equals y/x. So the y coordinate, the ratio of y and x coordinates should be equal to -3/7. Okay, so here is this the x, the y. So we can pick x, y to be what? The ratio to be -3/7. But keep in mind, in the second quadrant, x is always negative. So we can pick x to be -3, y to be 7. Of course, you can pick other numbers, but you need to keep the ratio to be -3/7, right? So this is a very convenient integers we can take. So we have r, so we can calculate if this point is -3 and 7. So we can calculate the distance, which is -3 minus 0 square plus 7 minus 0 square. Take the square root. So it's equal to the square root 58. And the cosine theta, the terminal side is on this line, and equals x over r. So this one is equal to x is -3 over square root 58. So here is one important thing is why we take x to be the negative, y to be the positive. The reason is this point is in the terminal side is in the second quadrant. The x coordinate always be negative.